Hi everyone, welcome to my channel. Let's learn the algorithm together. Today we'll take a look at the 3 to 5 maximum size subarray sum equals k. And what is this problem talking about? We'll be given an integer array numbers and an integer k, then return the maximum length of a subarray that sums to k. If there is no 1, just return 0 instead. So first of all, what is the subarray? Subarray means that in current array, we will have a contiguous array within that. So for example, like now we have these numbers 1, minus 1, 5, minus 2, 5, minus 2, 3. And then the subarray could be like minus 1 to 5 and minus 2, or 5 to minus 2, or like this, 1 or minus 1. But we cannot like have something like 1, 5, and minus 2. These three numbers cannot be a subarray. And since already understand what is subarray, and now it says we need to sum up like all the numbers in that subarray. So for example, like if we have this subarray, the sum of it would be like minus 1 plus 5 is 4, 4 minus 2 is 2, so the sum is 2. But now the problem is like we need to calculate which the sum of the subarray is equal to 3. That's what we required. And how are we gonna do that, right? Of course, I'm gonna think like probably we have what, 2 pointers, something like that, and now each time one is for the left side and another is for the right side, and we remove these 2 pointers. And for example, if we are having at this kind of position, and then we start to sum up all the numbers in this range, right? So once we sum up this, the results could be, how are we gonna do that? The time complexity would definitely really high. For example, because like the left pointer is starting from our left side, and the right pointer will move also from equals to the left, and then move to one position, next position. Every time doing like this, at least how we construct like all the subarrays, the time could be, first is O(n) squares, because we are constructing this subarray, right? After we go through the whole array and calculate all the subarrays, the time will be O(n) squares. And also in mile, we have to use another pointers to go through like from the left pointer to the right pointer, and then get all the sum of it, and that will be another n. So the total time could be like O(n) 3 times. That's pretty high. We don't want to do that like this. So how can we improve that? Now there's another problem inside that, and I'm thinking that could we like store, calculate the sum so that we can remember it, right? So that we could save us some time, just like we do in other problem, like when we already see these numbers, we remember it. So when we are going to the next number, and I can remember that, yeah, I saw that before, right? So using another data structure to remember something could save us some time. And also, actually, when we are seeing the problem talking about subarray, and sum. These two keywords can bring me up using a technique called PrefixSum Technique. If you are not familiar with this technique, please watch another video from my channel, and it will explain you more details about it. But here I can also briefly to tell you what it does. It is something like when we are going through this array, while we go through this array and we calculate the sum of the current number with the previous sum. For example, like now we are getting like the sum will be 1 because we only see one letters, right? And we can say this is prefix sum. Prefix sum is just like we do the sum from the beginning letter till the current letter and then remember it. Now we only see one letter, so it could be 1. And when we move to the next one, we see the number is -1 and we add it up with the previous numbers, right? And it will turns out to be like 0. And then we move the pointers to another position and get it like 5, and with 0 plus 5 actually is 1 plus -1 plus 5, it equals to 5, etc. So that we will get a PrefixSum array doing that after we go through the whole array. And what is this PrefixSum help us? Now we know that like if we are want to get this, probably I use another color, right? For example, if I want to get this sum of the subarray, how we can do, since we already have the prefix sum, it means that the numbers from the 0 to here we already know is equals to 3, and also here we also know is equals to 0. So it means that this part is just equals to this part minus to this part. So we can like expression in this, the subarray sum could be like the prefix sum, like this is the end minus prefix sum start -1. And I hope you can like understand that. So the starting point is here, but we are going to previous one is 0 because we want to get from use this part to subtract this part, and then we can get the sum of this part. And this is how we got the subarray sum. So now we have this idea, right? And when we are going through this, and we can also like, while we are traverse the whole array, we are not only to build this prefix sum, we can also start to get the prefix sum, the current sum of the subarray. And since we want to know the maximum size of the subarray, it means that we only know like, for example, if we are also have another so if we want to get k equals to 3, it means that when we are going through this point, we hope to find this if there are any numbers, like if the prefix sum, the current prefix sum minus k and then is there equal another PrefixSum is equal to another PrefixSum. So, or probably we can say that like, now the current PrefixSum minus k equals to another PrefixSum. And we hope that if in the past we also have another PrefixSum, so it means that when we are building this PrefixSum, we also need to remember its index. And perhaps we have a map, and then the key is the PrefixSum, and the value is the index. So if this map tells us like, yeah, in the past we are having another PrefixSum, it means that we can get this subarray sum equals to k, right? And so once we got this, we can calculate the length of subarray. And the length of the subarray equals to like the current index minus to the prefix index, right? Prefix index. But now I have another question. It's like, what is the prefix index? If there are like two numbers exactly the same, which one should I choose, right? Probably like we also have another 0 or something like that. For example, if I also have a 0 here, and it means that the PrefixSum will also add one more 0, right? So how we decided which index we need? And now because this problem is talking about the maximum size, it means that we hope the index is far away from our current index. Like I would prefer this one to get the length instead of the later one, because this will make us like having the maximum size of the subarray. So now we also know that this index should be the first occur index, right? And I believe this is the idea how I should solve this problem. Like when we are going through the whole array, probably I can write like this. And now when we are looping the array, we start to construct the PrefixSum map. Oh wait. So yeah, how we start construct this this map? Like first of all, we need to calculate like looping this array. We need to calculate probably we just going back like this. Okay, so we still writing our pseudocode from this side. First, we need to get current PrefixSum, right? After that, we need to get the expected PrefixSum, the expect or another PrefixSum we set, another PrefixSum. So first of all, I'm thinking that, wait, so we don't calculate it. First, we need, when we are, yeah, sure, we can get another PrefixSum. And then when we get another PrefixSum, we check if the map contains another PrefixSum. Let's make it smaller. Contains another PrefixSum. If it has, we then get the index and then calculate the current length, right? And also we then update the maximum length, because probably we have another like maximum, but now we are comparing the previous maximum length with the current length, right, to see which is greater. And after all this, we also need to put current PrefixSum in the map. All right, yeah, so that's it. If the map contains the PrefixSum, we don't have to put it. But if map doesn't not contain the current PrefixSum, we also have to put the current PrefixSum into it. As I said, because we always want to get the first occurred PrefixSum, but if already have that before, we don't need to care about that. So that's why we only update it when it doesn't have it. And after all this, we are return the maximum length. But of course, if there's no, right, we can return 0. So at first, when we set the maximum length, we can set it as really small numbers, right? And if the maximum length is still equals to these really small numbers, it means that we cannot find any, just return 0. But if we find it, just update the maximum length. And this is one tricky part we need to remember, that because we are probably cannot find it. Another tricky part is we also need to like have another numbers before the PrefixSum map, like 0. For example, what if our k equal to 0 is our target goal, right? It means that like when we are getting these two numbers, we also want to return a 0 or something like that. So we have to add another one before. So once for example, like, let me think about that. Is it the current case we need that? Yeah, so if the k equals to 0, and when we are calculating like 0, we need to find whether we have 0 before. So we definitely to put 1, like -1, so that we can calculate the length of it. Right, so this is the tricky part. We have to put 0 before. And I believe that's it. And now we can start our coding part. Oh, let's step back. We have to also analyze the time complexity and space complexity. So the time for this one should be time. Because we only go through the whole array for only one time, so it should be on, and means the numbers of the the numbers of the elements in this array. And the space, since we are using like another data structure like the map, and the worst case is like all the prefix sums are different, so we also need on and equals to like the numbers of the prefix sum, and the worst case is like every prefix sum is totally different. We have to sort it. So this is the time complexity and space complexity. And now let's move to the coding part. In here, as I said before, first we need to think about have a map, and this is for the integer prefix sum, and also the index integer, and we can say prefix sum to index map, and we are using a hash map to initialize this as a key value hash map. And hash map is pretty fast for look at something based on its key. And then don't forget to put the first prefix sum into it, 0, so that we can still like getting the sum of the first, like starting from the first letters, tell anyone. If we don't have that, we cannot get sum of the subarray that is starting from the first number in the array. And this first thing, another thing is we need to have a maximum length and initialize as a minimum value, so that when we are checking that, when we are return the result, we need to check that if the maximum length equals to the minimum value. If it is, we just return 0, else we are return the maximum length. And other than that, yeah, that's it. We can start to loop this array, and for each number in the array, oh yeah, because we need the index, we have to use the I equals to 0 to go through these arrays. And then first thing is we get the current prefix sum, and that would be like, yeah, so it means that we also need the prefix sum to help us like getting it. So the current prefix sum equals to the previous prefix sum plus current numbers, and then we calculated another expected prefix sum. Does it exist in the prefix sum map? If it exists, so that we can get the sum of the subarray equals to k. So integer is the expected prefix sum equals to current prefix sum minus k. So if the map contains k prefix sum, then we can calculate the length and then update it or not, and that will be like, you can just get the index of it and decide whether we update or not. And if not, there's nothing changed here. And also we need to check if the current map have the current prefix sum. If it has, it doesn't have, we need to pull it into it. So put prefix sum and the current index, and I believe that's it. So now let's run it. Oops, there's a wrong answer. So now, for example, like we also have the 0 in the map, 0 equals -1, and our expected k is 3, and when we go through the first letter, it's 1, and it equals to now 0, and then it goes to 5. 5 is -3, but of course, alright, so the first letter we should not put -1. We can starting from yeah, let me think about. So if we want to get the length of this one, this will be 0, 1, 2, 3, and it equals to 3 minus 3 minus -1 equals to 4. We should get 4. Oh yeah, when we are getting this value, we should, using current one, subtract the previous one. And now let's run again. Cool, so now it passed. So here I forget that how we get the current length. The length should be current index subtract the previous index. And now let's submit it. Cool. So we pass all the test cases, and this is the idea how I solve the problem. When we are seeing the problem, like calculate the maximum size and or subarray sum, something like that, we need to think about using a technique called PrefixSum Technique. The PrefixSum Technique helps us to memorize some previous calculation, so that it will help us to get the sum of a subarray. And I believe that's all we need to learn from this problem. So if you think this video helps you, please give me a thumbs up. That would be great encouragement for me. And thanks for watching. See you at next video. Bye.